Hi everyone. So today I will talk about unstructured mesh. That's a new technique that we are using for geophysical modeling and inversion. And I will bring some examples coming from our project that we have done so far, some of them. So the story of GeoTextura starts with, it was around maybe 2020 that we started GeoTextura to bring the software Magnum from academia to the industry. And the software Magnum was work on this software over maybe 10 years, and it was using different academic projects. And it's really powerful software. We believe it's the most fully functional geophysical inversion and modeling software, which means we put all tools that we need in this software and many features and many tools. And also, everything is on one platform, which make it easy to add all different type of the data, including geological data as constraint or prior information, and geophysical data. And also it uses unstructured mesh. This is what I focus on. And I will show you some example in my presentation to see how unstructured mesh can improve the geophysical modeling. So yeah, in GeoTextura, we have done many projects since 2020 in different countries around the world and in different type of the exploration, mostly mineral and metal exploration. So the first things I want to show you, it's the simple example of what is unstructured mesh means. You can see here, this is unstructured mesh. These two here on the left side and the middle are the structured mesh. So when you want to, this red line is like a surface. It can be topography, it can be a geological contact. And when you want to reconstruct or generate this surface in using the traditional method structured mesh, it would be something like this. It would be like step shape, the cube would be like this. If you want to improve it, you might be able to use the quad tree or octree mesh, which means you make a lot of small cells on the surface. But this is not the best things, because increasing the cell numbers, which make your inversion very expensive, the runtime, the CPU, everything would be cost a lot, and everything, it takes time a lot. The best solution is use the unstructured mesh, which you can see with minimum cell size, the exact topography or surface you have, it can be added to your geophysical, to your mesh, to your inversion mesh. This is a good example of the inversion data of the gravity, inversion of gravity data. This is the structured mesh. You can see that this is the topography, and this is the unstructured mesh. You can see here the topography. There is a huge difference, and I mean, this is not representing really the real geology. This is the real geology. So this is a good example to show what means the surface, what means unstructured mesh, how can keep the highest resolution of the surfaces in the geophysical modeling. This is another example that we did maybe a couple of years ago in China. So you can see here, unstructured mesh generation make it much easier than structured mesh. For example, here, in this project, we have drone survey, and this is just a small part of survey. Drone survey were scattered everywhere. So if you want to refine the cell size under this survey to have a better resolution of the inversion, it was almost, I cannot say impossible using the structured mesh, because you need to make a lot of small cells. Again, it would be very expensive, but using unstructured mesh, we were able to refine the cell size under the survey line and have a perfect control on the cell size and the resolution of the inversion. And of course, when you have a smaller cell size, you have a better resolution. While you don't need a lot of, you don't need really a smaller cell size outside of the survey line. There is no point. And this is a geology model. This started from, I think it's in Ontario, if I remember, Ontario. So these are like geological surfaces. It's like a complex model. So we can add these surfaces into the geophysical model with the highest resolution, exactly the way it is. And the output can be something like this. And you can see 3D model is generated using those 2D those surfaces. And this can be an input for our constraint inversion, which when we have this high resolution, we expect that we have a better or a more reliable inversion results as well. So I mentioned about our software. It's not bad that I just say what is the software. This software, we call it one platform for everything. I mean, we have added many tools and methods. For example, there are different inversion types that you can do: independent, joint, cooperative, constraint, or clustering, constraint, joint, any combination of them. Everything is on one platform. You can take advantage of one of them or many of them. And even for the inversion methods, we have different types. I don't want to go through technical things, but some of them are very new technology, like surface geometry. This is not something you can find it everywhere. But my examples here are the mesh-based. And also, to this platform, so far we have added different geophysical data type. For example, magnetic, gravity, gradiometry, seismic refraction, muography, IPDC, magnetotelluric, and other EM methods will be added soon to this platform. The point is that why we need all these things? Because if we want to have one solution or one method for different type of the data, it might not be a best idea. Each data has its own challenge. It comes from a different geology. So we might not use one method for everything. So sometimes we might need independent inversions or maybe joint inversion or a combination of them. And also sometimes we need to take advantage of the geological information. And the point of developing the software at academia under the supervision of Dr. Colin Farquharson was to have everything on one platform. If you have a challenging data, we can deal with it in a right way. So I just want to show you a few examples. This is examples of the inversion of IP data. This is the project was in British Columbia. So you can see the topography here versus the inversion results done by another consultant using the different software, using the structured mesh. This is unstructured mesh. This is our results. So the topography generation is not really comparable. Of course, unstructured mesh, as we expected, it has a better resolution. And also the results are different. Our client mentioned that our results is closer to the geology. The other good example I would like to show you, this is, so we know some of you might be familiar with 1D and 2D inversions. That's good, very fast, but not always the best things. They have their own weaknesses. One of the main things, they do not really consider the topography effects in the data. So here you have 1D inversion model, a model made from the 1D inversions, and versus a 3D inversion using the unstructured mesh. There is no similarity between them. Both of them are the inversion from one type of the data. And the 1D inversion is absolutely different, and the 3D inversion is matched perfectly with the geology. Actually, our client came to us because they had some drill hole based on this 1D inversion, and they ended up in nothing, so they were wondering maybe there is a problem with the data or the tools. So when we tried the unstructured mesh, it shows that it's just about the technique that they use. The data is perfect. There is nothing wrong with the data. Just the technique used for the interpretation was not right. And yes, using unstructured mesh helped us to add the topography to this model with the highest resolution to increase the results. Another example I want to show you here is about using different techniques. You can see here on the top is the inversion results of the gravity data, which is the density model, and this is the inversion results of, on the bottom, the inversion results of the magnetic data. And we start from the left side. This is the independent inversion. If we stop with this, that's it. This is very traditional and common method. But we didn't stop here. We did joint inversion. Joint inversion is when you take advantage of two different types of the data at the same time in your inversion algorithm, and you try to generate one single model. So the joint inversion here increased the results significantly. There is an unconformity here, which is matched with the geology between the basement and the upper part, which is the bedrock. And for the joint inversion, we have different methods. For this, we use the fuzzy seaming method. So we didn't stop here. We did one step further, and it was constraint joint inversion, which means we brought geological surfaces, physical properties, and geological information from the real holes, and borehole information into our model to improve the model. And the output is like this. The overburden is reconstructed well. The basement, the anomaly in the basement are reconstructed well, and even there is a fault here, which can be seen here in this model. So this is just a point. Sometimes one method is not enough. We might need to try different methods. Just two more slides here are about the forward modeling. I would like to show you forward modeling, when it can be helpful. Forward modeling means synthesizing geophysical data from an Earth model. When it can be helpful, before you have a survey, you don't know, for example, can you see any response from your target in the geophysical data or not? And the survey is expensive. Forward modeling can help you here. We generate an Earth model based on the information you have of your geology, and then we synthesize the data from that model. And then you can see if the signature of the target is enough strong in the data, how about if there is a noise, and many other things. So this is the advantage of using the forward modeling. Here you can see that using the unstructured mesh, we added a topography with this highest resolution and some anomaly under the topography, which this is the privilege of using the unstructured mesh. So help us to have a results with a better accuracy. And the last slide, we can usually it's geophysical forward modeling and inversion are for the interpretation, but even we can take advantage of the unstructured mesh for the processing method. You can see here there is a topography. This project is in the Athabasca Basin for the uranium exploration. So you can see here the topography can be seen. So the middle figure is the gravitometry data after the train correction using the conventional method that they used. You can see clearly the signature of the topography is still there. Why? And it shouldn't be like this because it's after the train correction. And this is not, maybe the train correction is not really helpful to the method that they use. We tried the forward modeling for the train correction, and since unstructured mesh enable us to have the high resolution topography, so we were able to reduce significantly the topography signature from the data and have a model like this. And yeah, in general, there are 2 points. One point is that unstructured mesh help us to add the data with highest resolution, the surfaces. So of course, from the output, we expect that we have a better high quality data, high quality inversion results, or better quality inversion results as well. And also, always one method might not be enough. We might need to use different methods to make sure that we are getting more reliable results. And yes, that's it. Thanks so much. And if you have any question, you can talk to me and also email us.